This is the first of 5 Tech Time sessions that we're running at this year's FESPA, and they're all hosted by me. But I have a different panel of distinguished people for each one. I won't say what I said last year was I found them in the corridors and brought them in because they didn't have anything to do. I think that's a bit unfair. The topic that we're covering this afternoon is kind of a look at where can we go next with wide format digital print, more for graphics, but if we touch on parallel markets, obviously a bit of industrial, perhaps a bit of interior decor. I haven't even bothered with questions this year because you start with the 2 words and end up talking about something completely different. If anybody's got a question as we go along, if you stick your hand in the air, I can just ignore you, or I can get somebody to bring you a microphone. I hope you'll find it interesting and that you'll want to stay to the end. First of all, I'd like to introduce my hand-picked panel of experts. And on my left, we're sharing microphones because we love each other.
Good afternoon, and as Sophie said, thanks so much for coming. My name is Ken Hanulek. I'm the Vice President of Marketing for EFI's Inkjet Solutions business.
I keep the microphone now. Martin.
Hello, my name is Martijn Vandenbroek. I'm from a company called Screen. I'm the European Product Manager. Most of you probably don't know Screen, but Screen is a company that's coming from the graphic arts market and has a wide range of inkjet devices and also in the wide format market nowadays. So very interesting products, and you will learn about that more.
And last but not least.
Hi, my name's John Mills. I'm the CEO of Inca Digital. We've been in wide format now for 15 years. Very large format machine, the Onset, which you'll see on the Fuji stand in Hall 6. Free advertising to start with.
Advertising's forbidden. Okay, so I think what we're going to start off with is I'd just like to know from these 3 people that all come from similar market areas, but with very slightly different product histories. I think you played the screen element down a little bit because obviously Nippon Screen is a very big manufacturer of which wide format is just a part. Should we start with you? When we come into wide format in the graphics side, where can you see it will go next?
Well, I think the inkjet in the wide format market is very new. Especially the UV inkjet. It's only 10 years old, and well, if you compare that to conventional offset, that's very minimal. So I think there will be a lot of innovations coming, a lot of new possibilities. But I think in this moment, what is most important to see that productivity is going up. Why? Because people can produce more efficiently. There's price pressure is now evolving, so you should be able to produce both high quality and very efficiently, and that means at high speeds.
I'm just going to follow you up on that before we go on to John. You see that the emphasis is more on the high productivity end of the market rather than the lower entry-level side.
Yeah, what I try to say is that there's a lot of machines out there that produce around 20, 30 square meters an hour. And in order to be competitive, they have to start producing faster because the overhead costs, labor, building cost, electricity, that part is quite high per square meter. So if you are able to produce 5 or 8 times as fast, then that cost is really gonna go down per square meter, and that's quite important to keep being efficient in the market.
John, what's your thought on this one? Can you share his mic, okay?
Yeah, I think the challenge for any of you guys walking around the show is that it's very difficult to actually tell the difference between any of the machines. So print quality now is a given. If you go to any of these stands, the print quality will all look great. And so how do you differentiate? Then you look at throughputs, and everyone has a brochure, and the only thing I can say is that the throughputs you see on the brochures of anybody is never what you get in reality. So how do you actually get past those things? And so customers, I think, find themselves in a situation with how do they differentiate? So as suppliers of equipment, we're always trying to give our customers ways of differentiating them against the competition. And I think that what you'll see from Durst later on is there's new ink coming out, which is really interesting. I think the ink is going to be one of the things that differentiates, because you'll see people going into textiles, a lot of talk about packaging and other markets. I think the standard point of sale graphic market is becoming very, very tough. You know, there's all these competitors in there. The technology has basically matured. Everyone's migrating roughly to the same solution. And so we're all looking for new and interesting things to do. And I think that industrial markets is one of those areas. Textile printing, that's where we're having to migrate, because the standard point of sale graphics market is becoming quite difficult to differentiate, both as a provider of equipment and as a supplier of printing to the industry.
Now, Ken, I'm going to be interested to hear your view on this one, as you cover all bases, as it were.
So I sort of agree with my colleague John, directionally anyway. What I see from customers and prospects that come to the stand here at FESPA, they're trying to do two things. They're trying to lower their costs, or they're trying to come up with ways to grow their business via innovation and differentiated solutions. We offer technology in terms of printers from 100,000 euros up to north of €1 million, and virtually 19 different categories in between. So there are a lot of printers and technology that produce amazing image quality, very reliable, and have good track records. I think where the value add comes in, when you start to leverage in the ink sets, as John alluded to, you leverage in the hardware, the printers, the software, and then also the capability of the organization around all that technology to put it together and help drive costs out of your businesses, and then have the opportunity to introduce new technologies that help you innovate.
This leads me on to, it's a question I actually asked in the EFI press conference earlier, but I know traditionally John is from the flatbed market. You're more flatbed than roll-fed-ish.
Well,
hang on just a minute. And Ken is from a company that produces both. Do you see there's going to be a specific growth in rigid production rather than roll-fed, the other way around? How do you see that balance? And let's start with you.
Well, I think it's very important. You see that people are looking to print dedicated flatbed. So not really, people that have belt systems, they often run into limitations like accuracy or the ability to print double-sided. So you see a lot of people now really looking to print on a dedicated flatbed device. But of course, at the same time, they'd like to utilize the machine also to print reel-to-reel work. So, and that's why also Screen now released a roll system, really a professional roll system that can print high quality, high speed, unattended. So then during daytime, people can print on a real flatbed device, and in the evening when they leave, they can leave the machine run unattended and finish a roll of raw material to diversify their market.
Yeah. I think it's quite interesting though, because the faster the machines get, the more attention they need. But that's another question. John, what's your view on this split? Because it's not one that's so much affected you, has it?
I think that the flatbed market for us, most of our sales are in flatbed, and we see that as a market that's not going to grow hugely over the next 5 to 10 years. And so we're looking into other areas. So Inca are going to be producing other types of machines to grow. One of the areas, though, that we do see some interesting growth is that if you look at the offset markets, there is a section of market, both in offset and in corrugated, where people will actually print digitally and then laminate to a board. And that kind of litho lam business, where it's traditionally done printed litho on an offset press and then laminated on there, taking the small runs off the digital press, off the analog press onto a digital solution, makes your analog press more efficient. So I think one of the things that's actually strangely driving adoption of technology in other areas is people are under more and more pressure to make their analog presses more efficient, taking the short runs off the analog and moving them to digital. And so where And where that saves process time, so it's not just about the print, it's if I can actually print directly to board, then I don't need to actually print and then laminate and do all those post processes. So actually for us, we're seeing quite an interesting change as there's more pressure on analog print. It's actually driving adoption of flatbed in other areas. So that's one change that we're seeing. But the roll-fed market and flexible media is probably 6-7 times as big as the flatbed market. I mean, ViewTech is, it probably sells more flatbed machines than we've ever sold.
We'll ask him in a minute.
They've sold more machines in a year than we've probably sold in a whole lifetime. So it's a very, very big market, and I do see growth in there. One of the other factors I think is interesting, if you look at some of the other territories, if you go into Russia or Indonesia, some of those territories where there are very, very big outdoor markets that have driven a lot of adoption of the 5-meter banner machines, there's legislation coming into those countries that are driving from the big outdoor signage to more indoor signage, because people do not want to be bombarded by thousands of outdoor 5-meter banners. So that kind of is driving print quality requirements down, because as you go inside, viewing distances are shorter, therefore you need higher quality. So that also lends a bit more to higher quality roll and higher quality rigid. So those are the things I kind of see in the market. There's legislation that will drive through to that area.
Well, my next question is going to follow on from this, but I want to hear Ken, Mr. Rollfed.
So I think in order to answer the question, you have to ask either what type of business or vertical market are you? Are you a commercial printer? Are you a screen printer getting into digital? Are you a display graphics shop? And then I think you have to look at the applications you're trying to produce. And I agree with all of John's comments. If I start at, say, a commercial printer that's interested in diversifying their business, coming up with new revenue streams, they'll likely start with an entry-level, what we call a hybrid device. That's the capability to image on rigid substrates as well as roll-to-roll substrates. And then there's a whole host of products that address many, many bands, and it's really all around price performance. So if you want to get a machine that starts at 4 boards an hour, you can do that at a very low cost of entry. If you want to have a very highly productive machine that does 70 or 100 boards an hour, you can do that, and obviously that's got a different price point, but there's many different bands to get in. And I think as you go up market to very specific applications where there's volume play, that's when you start to see people convert to a board-only machine or a dedicated roll-to-roll machine. We announced at our press conference about an hour ago a very fast, flexible roll-only machine that's capable of printing 230 or 300 square meters an hour, 3.2 meters wide, to address some of the very applications we're talking about. So I think as you go upstream, the market kind of separates naturally based on application. As you kind of get to the middle market, there's a little bit more room for flexibility. Interesting, we sell probably about 60% of our machines start, or when we go into a customer start, as a hybrid device. And as their business grow, their second machine is usually a dedicated roll-to-roll device, so they can naturally segregate their business.
Just following on from that, and I seem to have ended up with both microphones, so I don't think it matters. Which one would you like?
I like yellow.
Yellow or blue? It's a bit Kodak. Oh, I didn't say that. Right, so you've got, I've lost the plot now. No, I haven't. Just a comment that John made about the markets where you've got super wide format or 5 meter. I've noticed quite an organic change as droplet sizes have got smaller, and those print heads and the droplet benefits are now going to appear in the super wide machines, which means that you're not restricted to a distance viewed object which has got, I don't know, a resolution of, in the old days we get excited about 8 dpi and wildly excited about 32 dpi. This actually now means that you could buy a 5 meter machine but use it as a multi-roll to print jobs 3 up, because you're going to get the same quality off a 3.2 or even a 1.6. Do you agree with this kind of philosophy? Do you think the print head quality, the droplet quality, has driven people more to roll fed because you can now use it more realistically for closer viewing? And you're going to say no. John's going to...
Yeah, I think that the thing about droplet size is that there's a trade-off. If you go for small drops, then you get lower throughput. You know, if you want very high throughput, you have big drops. So if you're looking at something that's printed here, you guys are sitting there, anything less than a 30 picolitre drop would be an utter waste of money for you guys, because this you would not be able to tell. So if you look at the eye's ability to determine different resolutions, if you go below 10 picolitres, from 10 to 7 picolitres, unless you are within 40 centimetres of your eye cannot resolve the difference. As soon as you go to a metre, it might as well be 14, 15, and as you go back. So it very much depends on what you're trying to sell. And if you're trying to sell a certain type of print, then you want to go as fast as you possibly can for that quality, because then you get the lowest cost of print, and then you'll be able to make more profit or sell more. So I think that droplet size is one of those things that's market specific. So we've got a range of products, and we go down to 9 picolitres, but we tend to find that all of our machines now, the biggest seller is 14, and we could go lower, and there are 7 picolitre heads available and 2 picolitre head. I mean, you can have whatever you like, but the reality is that you trade off throughput and performance. I think on big wide format, large distance viewing, I think that you're going to continue to be sort of larger, 30 picolitres, and for the kind of very high quality cosmetic backlit, I think probably 10 picolitres is absolutely fine.
I bet Ken's got something to say on this, but Martin continues thinking. Can I just hand this to Ken next, because I think this is one of his...
So I think certainly drop size plays a big role in equipment selection. I do think as the main market continues to adopt digital technologies, as we try and take work from the analog processes that exist today and convert it to digital, it's important that it is artifact-free and near photographic quality. We have 2 technologies. We have a 12 picolitre, which has been around for the past 7 or 8 years, and now about a year ago we introduced what we call our ultra drop technology. It's 7 picolitre imaging. We have no performance hits when we go to that, so you get all the same price performance that you achieved on the 12 picolitre, but you have the capability to have 4-point reverse text. You have perfect gradations. You have amazing flesh tones in terms of 3/4, quarter tones, the difficult areas that you tend to hit when you're doing very fine imaging. So I think as the market continues to embrace digital, it's really important that you have very, very fine imaging heads.
Yeah, it's quite interesting, drop sizes, talking about drop sizes, big, small. Actually, maybe more important than drop size is the drop placement control. So where exactly do you put a drop? If you have a very small droplet, it's very hard to control. And if it doesn't come in the right position on the media, you will not have a good quality. You will not get a sharp text. So what you typically see with smaller drop sizes is that the speeds are diminishing. So typically with when you go with a 7 droplet, you go down a bit, dramatically in speed. And of course, when you're doing a big investment, you're not buying a big machine to run it very slow, because you should have a huge margin on that work with a fine droplet, because in the same time that you run 1 hour a 7 picolitre droplet, you could have run probably 7 or 8 times as much normal work. So how you make that up with your margin, I don't really understand that. So if you have one droplet size, a good droplet size, we use 14 picolitre. That's a very good balance between speed and throughput. You need a certain amount of ink to put down to get good color density. So with the 14 picolitre droplet, we can do very high quality. We can run it at 150 square meters an hour, but we can also make photo quality. And what is very impressive, when you have the drop placement right, you can also do lenticular. So we can print lenticular on the 75 LPI lens, but also with the 14 picolitre droplet, we can run a 3 picolitre readable text, and even we've gone down to 2 picolitre. So how important is drop size? If you can get that fine text, you can print it with that drop size. So is it worth having a smaller droplet running a lot slower, or running good speeds with a slightly bigger droplet. So that's a little bit the question that you have to ask yourself.
I'm going to hand this back to Ken next because I have a feeling he's got something to say on this one. I do have a question of my own though. I can't read 4 picoliter. I certainly can't read 2 picoliter text, or 2-point text, sorry. I think sometimes it does get a bit crazy. I find it bad enough reading 12-point text, even with my reading glasses on, but that's beside the point. But it's the droplet placement thing that I found interesting, was what you were saying there. And I suspect Mr. Hanulek on my left might want to add something to that and how they get around it.
Yeah, so I think we could have a big technical debate about drop placement and drop size. Obviously, we spend many tens, north of $100 million on research and development each year to understand the best price performance for the given technology that's available at a given point in time. I think as our customers do their discovery before they make an investment, they generally go through 4 processes. So our sales organization does a complete discovery to understand what the customer is trying to accomplish. There's usually a period where there's some samples and demonstrations to illustrate the capabilities of the technology. There's usually a demonstration where they can come and run their work on the given printer they're looking at. And then there's the opportunity to do a complete business analysis, including an ROI justification as well as a total cost of ownership. What's each piece or each square foot can actually cost based on drop size, based on ink yield, based on the price performance of the equipment. So I think as you look at all the different suppliers that are here at this FESPA 2015, it's important that you consider all those factors and make sure you go through that complete kind of business audit and understand the technology and what it's capable of. As far as absolute placement on the sheet, we've got 6 different roll-to-roll printers that are running 7 picoliter. We've got 9 different hybrid printers, and we don't see placement accuracy as an issue, and I think that goes into some of the engineering capabilities of the given hardware.
And on that note, I'm going to ask John his thoughts on the same thing.
I agree with Martin. Drop placement is absolutely key, and we have all sorts of difficulties trying to get them in the right place, and to do it because you're effectively trying to control 4 billion drops a second, and to do that while the bed's moving at nearly 2 meters a second over that area, it is pretty tough. And if you look at 4 and 6-point reversed out text, then it's very difficult to keep that across the whole area. And the other factor which really determines text quality is the satellites that you have, because every inkjet printer in the world, you have a main drop and you have a satellite drop, and it's what happens to that second drop that really determines how good your text quality is when you get down to small features. Because you've got one big drop that lands, and then whether the second drop actually merges with the first drop or whether it's separate. And if you get a little magnifying glass and you walk around and look at the text around the show, you can see if it's a scanning machine and the carriage is moving slowly across like this, then it should be kind of quite tight, the text. If it's moving really quickly, you'll actually see the text will be a little fuzzier. And so if you get a magnifying glass, look down there, you'll see around the characters a little halo of very, very fine droplets. And on big text, you don't see it. When you go to very, very fine text on a reversed out, those little droplets tend to fill in the middle. And so one of the things that really defines the text quality is a combination of the ink and the head, because that will determine the satellites that you get, how fast the carriage is moving, because it's whether, if it's moving very slow, the little drop will always land on the big drop and you don't see it, but if it's moving quickly, the little drop will land in a different place. And so all these factors come into print quality. And so we could actually go to our stall and stand now, I could set the machine up and you'd have print quality. We could print a 2-point text and it would look beautiful. And I could guarantee that none of our customers would be able to do it in the real life because they'd all print too fast and it'd be tough. So there's a real difference between what you see at a trade show and what you see in the real world. And the challenge is always, it's a dynamic situation. So temperature, changes in substrate, changes in environment, changes in static. There's so many other factors that go into print quality. So as you go to finer and finer features and finer droplet sizes, you get to a point where actually those external factors become as important, if not more important, than the drop size. So if you want a robust printer that's going to give you the most reliable print quality over the widest range of substrates, a bigger drop helps to do that. So when you're looking at an industrial solution, you've got to look at what's the best print quality that I'm going to achieve year in, year out on every single substrate, in all environments, in all temperatures, with whatever static. All of that it goes into the mix. So I think there's the drive to smaller drop sizes, I think will, in the points of sale world, will probably not go much further than 7. I think that 7 picolitres is probably as small as you're going to practically get for point of sale. Beyond that, I think you lose it becomes too difficult to do. I think if you go to things like the Samba print technology, which is down at 2 picolitres, which is the real offset quality type print, I know the challenges that those guys have to actually get print onto to a substrate, and it is incredibly difficult. So I think that the world will all migrate down to better quality, but I think external factors will limit what's practical day in, day out for drop size.
There's a couple of things I'd like to throw into what you've all said. One is obviously the difference between binary and grayscale when we're talking droplet control, number one. Second one is how you control the droplet before it hits the media, which would be pin and cure or pinning technology, number two. Would any of you like to comment on that aspect, or am I boring everyone?
Yeah, well, if you can tolerate a bit of tech. So if you have a substrate and the substrate is completely flat, I mean, flat within microns, then if you have drops that get sent out from a print head, then if you want the drop to land here and the head's carriage is moving this direction, you've got to set the drop off there because it will land and do this. If you have 3 different drop sizes, if you're driving down the freeway and you throw a big ball, a medium ball and a small ball out the window, they'll all land in different places. And so if you're going very quickly and you've got 3 different drop sizes, then it's very difficult to get them all to land in the same place, right? But electronics and software will sort that out for you to do that. So they all land in the same place. But if you actually have a substrate that varies in height, even by 10, 20, 30 microns, then the drops will then land in different places. So if you're printing in the real world on a substrate that's going to vary by hundreds of microns in flatness, like a piece of corrugated or a piece of diode, then you are not going to be able to get the same print quality on 3 different drop sizes as you would if all the drops were the same size. Because if they're all dropped the same size, then even if the substrate's a little lower or higher, the drops will land at the same place in that line. And so we don't use grayscale heads for very high speed printing because it becomes more and more challenging to actually get good print quality when you've got grayscale heads when you print very quickly. If you've got a slow scanning machine and it's just the head's moving slowly, then it works extremely well. So what we do is we actually have a technology where we can vary the drop size, but we drop it from 14 picas to 11 picolitres on the head, or you can move it from 14 to 17 if you want to go quicker. But we retain the same droplet size because you get better print quality because all of the drops are the same size. And there's a very nice paper that HP wrote that completely disagrees with everything I've just said, and why their kind of grayscale head technology is so much better than anybody else's.
Martin, have you got any thoughts on this one? I'm not ignoring you, I promise.
Yeah, it's all about drop control. I agree, and you got to think how much a multi-level grayscale head. That's where you can fire the different droplets. I think John very well explained how difficult it is to control at higher speeds. So you can only use that at lower speeds. It's really that's also why Screen have chosen for.
What are you calling a lower speed in these days, roughly?
Well, our lowest speed is 20 square meters an hour, 22 square meters an hour. So, and I think generally our machine is built to run at 150 or 100 square meters an hour continuously, also when nozzles fail. So it's really, we're talking about an industrial piece of kit that's built for producing continuously with high uptimes efficiently. Also, in case a nozzle fails, you can still run it at 150 square meters. So the technology, the reliability technology in it, technology to automatically clean the heads without using any ink. So that type of technology, that makes the machine more efficiently. And I think that's more important than a very old drop light size, because you have to see the quality at the 22 square meters. I mean, we can talk about quality, what is higher and what is not higher, but it's really, if you talk about quality, it's subjective. I think it's really important to put some prints next to each other, and I invite everybody to come to the screen booth in hall 6, stand U20, and really look at the quality that's coming out of that device, because it's amazing. It's a fixed droplet size, 14 picoliter, and I don't think we need a multi-level grayscale head in it.
I think Ken's got something to say on this one, haven't you, Ken?
On your way to the screen booth, we're in Hall 6 as well. I think John's there as well, so you can visit with all of us, of course. So EFI leverages grayscale technology. We leverage binary technology. I said we've got multiple different head technology. We leverage one other technology to help with the final image quality or image appearance, and that's the pin and cure technology. We have both mercury and LED systems on our very high-speed press called the HS100 Pro. We have the ability to freeze the drop or slow it down, and then do the final cure a couple passes later, so they kind of blend together. That gives you the ability to have a matte, a satin, or a gloss finish. Also, the capability in that system to control absolutely where those drops are going to fall, but the resulting quality is quite impressive. In terms of boards per hour, it's 70 boards an hour in very high quality, and 100 boards per hour in production quality, in grayscale or binary.
Thank you. While we're still talking about ink, can we just move slightly sideways as to what are we going to do with ink next? Oh, Ken, sorry, we've had a slight accident. You've knocked your bottle.
Sorry,
I think, water. But I think it was mine.
I'll let you know.
Thank you, Ken. I should be dying of thirst. It wasn't mine, it was Ken's.
You said move sideways.
No, I didn't. I meant the topic. These Americans, I don't know what you're supposed to do with them. And now I've lost the plot completely. No, talking about ink, what are we going to do with ink next? You know, we've got Durst doing something mysterious this evening, which I think I know what it is. We've got, obviously, I can see Terence sitting in the audience. He knows a little bit about ink. The whole thing with the whole UV curable concept, you know, has it actually turned out how we wanted it to do? What have we got to do in terms of touch, of low migration? What are we going to do with that, particularly with packaging and any interior applications? I think it's quite a major issue, which has been ignored for a lot of the time, even though I've been talking to people. But from my perspective, when these wide format digital machines first came in, they were for big signs hanging up outside. Didn't need laminating, bang them out, hang them up. Now all of a sudden, you know, you can touch it, you can sit on it, you can package food with it, which has been happening for some time. But how do you see the future of the ink technology? And who'd like to start? John?
So ink technology, so you have water-based technology, UV-based technology, and then a mix between water and UV. So water-based technology, simply, if you have just water, it's great, very environmentally friendly, you can use it for packaging, but it's very difficult to actually get it to stick on anything that isn't paper, and also it's very difficult to dry. And so that's one of the benefits that, you know, you can have, very good for kind of packaging, for corrugated. And so what you do is you take something like the HB latex, which is like a water rebase, there's solvent in there, but it has functional activity in there as well. So there are chemicals in there that make it cure. And so you take effectively a water-based ink and you put something in that makes it cure on the substrate. The problem is that the thing that makes it cure on the substrate also makes it cure in the heads. And so it's very, very difficult to actually keep your heads alive if you have a water-based ink that's been designed to dry on the substrate. So the question for you guys is, has Durst gone down the purely water-based, which is great because the heads will survive but it won't stick, or have they gone down the route where it'll stick on the substrate but you'll be replacing heads every 5 minutes? Then if you move away from water-based into UV 100% solids is great. You can do all the things about pinning and curing and all those things that you can do, and you can control the drops, but you end up with a very thick film. It's UV. Photoinitiators are typically monomers. Monomers will actually migrate. Migration isn't something that you can use for packaging. So UV inks are kind of limited to non-food grade type activity unless you go for more expensive photoinitiators, which are polymer based, which don't migrate, and therefore, but that's more expensive and more difficult. So that's another area that so people are going down the low migration UV. That's one of the big pushes. We have some of that technology. The one that I think is most interesting is actually aqueous UV. So it's water-based technology combined with UV, and I think the reason why that's interesting is that you have all the benefits of a water-based ink in that you have a thin film, low migratables, and you have the benefits of a UV in that you can pin and cure. And so I think what you'll see is an evolution of these machines, not getting faster, and because I think we've kind of got to the point where people are bored of speed and power and all of those things. They want more functionality. So I think what you'll see is more and more inks coming through. I think you'll see water-based. I think you'll see latex-like equivalents, and probably better, I think, that are functional water-based, but be careful of the heads. You'll see the aqueous UV, which I think is quite interesting, and you will then see low migration on the UV.
Can I just add something to that? I mean, we're all very much aware of the packaging side of low migration inks, but I think in interior decor some of the same principles apply. That there is a touch. Okay, you haven't got the problem of it migrating into food, but you could have the problem of it migrating onto people, for example. And
yeah. You've got to account for your 3-year-old licking the sofa, haven't you? That's the thing. Or if you've got any kind of human interaction, then people are going to get more and more interested in the inks that they use. And I think that the benefit of going down to water, people think, oh, it's water-based, must be fine. Okay, that's not necessarily true, but it's a good starting point. So I think Durst will be the first of lots of announcements of different types of inks over the next few years.
Interestingly, Durst started on a toy grading to get round the touch thing and said they couldn't find enough people interested. But that's another story. Who would like to answer this one next?
So I agree with all of John's comments. I think, certainly we have a large ink facility just outside of Ann Arbor, Michigan. We employ a couple dozen PhD and chemists. And I think over the next years, just like you've seen a lot of innovation brought by the hardware and the software and the head technology, you're going to see a lot of innovation around different ink technologies that help get us into some of these different vertical markets, like food grade packaging, litho thickness in terms of the film, ink film, and just some other things that will happen. But I think directionally, especially leading up to Drupal, you're going to see a lot of innovation come, not necessarily in terms of the hardware and the software, but really the combination of all of those to address new markets.
Yeah, I do agree. I think there's every application will require a special ink. So indeed, food will require an ink that has to have certain characteristics. And for other applications, you probably want an ink that's very flexible. For other applications, you want an ink that sticks very hard. So I think it's very difficult to design an ink that can do everything, but there will be more inks for each application.
I think we've probably got time for one more question. Shall I throw the cat amongst the pigeons? Ken knows what this is going to be, I think, but it's just there's been a lot of contention about the HG ban, which is it or isn't it going to take place in 2016? I now know that it isn't in our market sector, but it still could, and I don't know how long the exemption is going to run for. I've had several people buying a printer calling me and saying, should I still buy this printer because it's got mercury arc lamps? And there hasn't been anything sensible written down. I found out about 2 hours before we started this. LED obviously has come on a lot, but it's not everything. I'm going to ask you, I know Ken best on this one, so I'm going to talk to him last. John or Martin?
The thing with mercury arc is that you get a huge amount of UV light out for the power that you put in and for the pound or dollar or euro that you pay. If you could find an LED that gave the same UV output per pound or euro, then we would switch tomorrow. The problem is that if you make relatively slow printers, it's much easier to put LED in because you need less power per second in order to cure what you're printing. If you actually take our machines that are printing 3.2 by 1.6 meter bed in 10 seconds, you need an awful lot of UV power to cure. And at the moment, in order for us to be able to cure at those types of speeds, the cost of LED would be prohibitively high. So there's a point at which you can use LED because the machines are sufficiently slow. If you go above a certain speed, it becomes more and more difficult. You can pin, so you can actually use the LEDs to actually freeze the drop and stop them spreading. But in order to fully cure the ink, you still need mercury arc. So I think that LEDs are on a path where the price is coming down, and I think in years to come, probably within the next 5 years, they may well be cheap enough in order to do the full curing. But we have not seen anything from our point that says that for large format machines, we're going to have to switch away from mercury arc, not in the foreseeable future. For small machines where it's practical to do so, I think there's lots of technical and commercial reasons why it's better to use LED, particularly, and I think the main driver is not so much power consumption. There's a lot being talked about power consumption. I'm not a believer that LEDs will actually save the planet. I think that where LED really comes in, if you're printing on very thin substrates on a roll device where and a mercury arc puts out a lot of infrared heat as well, and if you're printing on thin substrates, it's the heat that is the problem, not necessarily the LED. So I think technically, I think there are good reasons why you should move to LED, and we would do it tomorrow if the LEDs were cheap enough, but today they're just not.
So who do we blame for the bad bandwidth then? That's so narrow we can't really use it, but that's another story.
No, it's the bandwidth. The UV that you get out is actually quite focused, and so you can actually, well, if you want to, there's deep. The shorter the wavelength, the more penetration you get into the ink. So if you have a long wavelength UV, it tends to cure the surface, and if you have a short wavelength UV, it tends to cure through, and you get better adhesion. So what you're finding with mercury arc is if you have there's two types of lamps. You know, one is with and without doping, and if you have doping, you get different wavelength and it cures differently. So one of the challenges is how do you actually get the inks to cure all the way through with a single wavelength and get the right kind of properties you want. So LED actually is not trivial to get the inks and the LED solution. So you know there's a lot of work to do. These guys have done a great job on doing that on their machines. I think that for us on the very, very high speed machines, we just cannot get the level of curing power out of LEDs economically today.
Who'd like to go next? Sorry? Martin, you go next.
Yeah,
See your thoughts.
I do agree with John. With our machine, I don't think there would be an LED that would be strong enough to cure. It's definitely something that screen is looking at, LED. We have other devices. We've got a label printer, which is also UV technology that prints at like a roll of 35 centimeters width at a speed of 50 meters per minute. So that's 16 square meters per second. There we also use LED curing, but just to pin the droplet, and after that we use mercury to do the final curing. So for pin curing, we feel it's a nice technology to add on, but really for high-speed inkjet, to really dry the ink well, to get a good adhesion, we don't see it's the technology at this moment for the speeds we want to print on.
Thank you. Ken?
So I agree with most of the comments. We introduced LED technology about 4 years ago. Today we have it across 3 major product lines. So we have it on our hybrid product line, we have it on our roll-to-roll product line, and we have it on our Jetreon digital label press product line. There's many benefits to LED technology. I do agree there's some economic boundaries at the very high end of the spectrum today. I believe like any technology that's changing literally month by month, and we've got a lot of visibility into that with over 500 LED placements worldwide in 50 different countries. There are power consumption savings. There are big benefits in terms of running costs by the ability to image on very thin substrates, and we believe it's just a greener solution because you're using LED and not heat and all that energy. So I think when we first introduced LED, we made a commitment to the market and our customers that we're going to propagate it across the product lines. The remaining product line that I need to bring that technology to is my super high-speed product line. I would argue that I'm halfway there with pin and cure, but not 100%. But stay tuned. There's always a lot of innovation happening.
So we covered that. Has anyone got any questions that they'd like? Is anybody still awake? Yeah? Any questions? Anybody want to ask anything? Oh, sorry.
Yeah, I'm actually from the exhibitors, but kind of a theoretical question. Going back to the drop size, do you see any correlation between drop size and ink consumption? Do you manage to optimize ink consumption with different drop sizes and different substrates?
Yeah, typically, if you use a very big drop size, because with UV technology, the droplet is immediately cured after laying down the droplet. So you can compare it to printing with a big droplet that you have like half soccer balls, so half domes of soccer balls. If you use a smaller droplet, then you can compare it to have like golf balls. So have like a surface of golf balls would be less volume than the big soccer balls. So definitely, the smaller the droplet, the less the ink consumption, up to a certain level, I feel.
In your golden number of 14 picoliter, is this some way you see some kind of optimization between quality, consumption, and speed?
Yes, I do agree. Yeah. It's you can lay down a very nice solid layer of ink in one pass, and it's really incredible what we get out of that.
Does anyone else? John would like to say something.
One of the interesting things we're seeing now is that at 27 picolitres, people would want to have light cyan, light magenta to smooth out the flesh tones because the drops were just too big. You got a coarse, grainy effect. So the lights were very important to kind of give you image quality. When you go down to smaller drop size, 14, 10, 7, the light colours become less critical. And many of our customers now are looking at the difference between 4 and 6 colours and saying actually 4 colours is actually pretty good compared to 6. And if you get rid of the lights, you save around about 15 to 20% on the ink consumption. So the decision that people are making as you go smaller drop size, if I go 4 colours, I save myself 2 sets of heads and 15% of ink. And that's probably the bigger effect that drop size has on ink consumption rather than just the film thickness that they...
You could put the argument in there that if you're using grayscale heads, you should only need 4 colours anyway, but that's another story. Ken would like to answer yes, and then Ken said enough. He's got nothing to say. I'm really sorry.
I agree with John.
He agrees. Everybody agrees with everyone, and I think we're... Oh, except for Martin. Nobody agrees with Martin. Oh, peace. I thought it's... Peace. I'd go for that, yeah. Yeah, but I'd like to... We've sort of come to the end of our time, and I've enjoyed it. I think it's worked much better not having any proper questions, because we're old enough to be able to talk something moderately sensible, I hope. I thank the people that stayed bitterly to the end, hung on and didn't run off and buy a sandwich. But I'd like to thank my team of Ken Hanulek. Please give him a little round of applause. And Martin, whose name I pronounced wrong, and whose surname I can't pronounce. And of course, John Mills, the inimitable John Mills, who was brave enough to come back for a second go of this. So thank you very much indeed, all of you. Thank you, and thanks for coming.